that in terms like of a nice integration of like engineering, animal behavior, ecology, space exploration. Like it's like all the things, right? And it's just taking the animal's natural derived behavior, um, um, making a model or mimicking that robotically, neurally, and letting it just be itself on a different planet and let it do what it does somewhere else and it collects data for us, you know? So that's one thing I like to think about in that realm.
I guess my question would be like, how does that? What is the addition of having the personality of an ant do? What advantage does it give compared to just like having the Curiosity rover going around and collecting the same data?
Well, because you look at the because a lot of thought has to go into like how you're gonna traverse different terrains.
So this one would be automated.
Well, this one you're literally just taking the success of how evolution has already engineered an ant's body.
Yeah.
You just replicate that. You just copy it.
Right.
So it's called like biomimicry. So you literally just copying what nature has already shown and is still showing to be successful. Um, in whatever morphological limitations or structural limitations that a individual ant face, they make up for in like emergent intelligence in terms of like problem solving like that and stuff. You know, so like building a bridge out of each other's bodies to reach a certain point or whatever. Right? They've been shown to be able to solve a lot of problems and bridge distances where one ant couldn't. So it takes all of that thought process out of like, how do we build it? It's just a matter of how do we get it there and copying everything else and just let it do its thing and like put some like satellite transmission technology in it to where it can like transmit the information back to us somehow. Um, I mean, I'm grossly uh, ignorant to like all the things that go into it. It's just that's just how I imagine like you can harness the power of nature and evolution to gather and explore different planets, or to solve different problems. You know, so I'm very much in the biomimicry um, field of
So this project you talked about, are they trying to map the human connection?
I think that's the goal
That's the
is
end
to
goal.
try to, but it's so many connections, like well off into the billions
Okay.
of like connections. And so they're trying to start with simpler creatures. Um, I think I'm not caught up with it, but I would imagine from a worm they probably trying to go to like a fly, perhaps. So same thing like with a fly. Like if you could engineer a fly, it's same biology and morphology. You can do the same thing. You know, um, yeah. And it takes all of that like coding how to code for every situation in which the system is going to face. Because you just let a fly be a fly.
Yeah.
In whatever way a fly, I mean, obviously, if it's like a super windy planet, I guess don't put a fly because flies don't do very well in wind here on Earth. So it's kind of just figuring out which in my idea, the way in which I what kind of spurs on my research and my endeavors um, in science and being a scientist is using that as a mechanism as to promote conservation. So like I feel like it's easy and people would be very they would be very open to the idea of like, hey, we should preserve this land because the species rely heavily on this land because this species does this particular thing that helps us humans, rather than, everything else is fine. But that's kind of like my approach to highlighting the conservation of certain species.
Right. So, where do you see, like realistically? I know you said that's kind of your dream,
Hmm.
but within like maybe the next 10 years or something,
Hmm.
what would be the implications of this project?
Give me an example.
Like so, say they've worked up to a fish or something,
Mhm.
and they have the complete neural mapping of a fish. They can put a artificial fish into a computer and
Mhm.
have it behave. How do you see that being applied for conservation or any other field?
Okay. I think it would be like, let's say that you create a digital landscape. Let's say this landscape out here,
Yeah.
and let's say it's an ocean. um, you simulate, anthropogenic forces, whether it be chemical, like putting waste
Yeah.
into the water, or plastics, or temperature. You can change the temperature. Model that. How we model like weather. Um, Now put this fish in there that that you could let kind of like just live in this world that you've created. Let's say you don't perfectly, but you like just close enough model the oceans as they are now.
Yeah.
And then you want to say, okay, well, hey, lawmakers, we're finding a lot of plastic in the ocean, or let's say these whalers, or they're killing whales. I don't know what their name is, but they need to stop. Anyways, um, they're putting this oil into the ocean, or whatever kind of problem that we face, or we can kind of like we could see. We could
Yeah.
literally simulate it and say that this is how this fish is not able to overcome. We can a lot of different things, but one thing I'm thinking about is like you could really show kind of like in real time, almost at least, what this fish would, could, and couldn't do. Like you could illustrate that.
Yeah.
Like, oh, this fish has a small mouth, and you could really show a lawmaker or whoever's in charge of whatever, like global economics or whatever, that this is how it's realistically, rather than just showing data and graphs. It's like that. You can say like, hey, look, this fish, you can literally simulate it. You can see the limitations, right? Kind of just as clear as like you would in like a Sims game, and like little people walking around. Um, yeah, that could be I think, a very powerful way to shift things in the way of conservation.
So
In
you think
the
it'll be better at, I guess, processing the results from experiments and turning that into policy to
Yeah,
actually make a.
or even running simulations as to like if we continue on a certain trajectory, this is how it's going to affect X amount of species that we've
Yeah.
created digitally, and let them like live out their lives digitally, um, rather than being like, oh well, let's just wait till 20. I almost said 2030, but that's like around the corner now. Let's Rather than wait till, let's say, the population of fish. Let's say fishes for all different kinds. Fishes, they're at like 70. Let's just give it a random number. They're 70 now. Used to be at 100, but over time they dwindle down. So 70. Um, 70% of diversity. Used to be 100% diversity, and increasing, but this is diminishing in diversity. That's a good like little whatever. So instead of waiting, it's 2026 now. Instead of being like, oh well, I'm gonna just collect samples and kind of like look at the history, like, and stuff, and try to build up this whole case of like morphology and environmental data, all types of stuff, to make a case as to why we should save this. Because most people is like, well, even with this, what we're talking about, most people would be like, well, most policymakers, unless you give a good enough reason or whatever are gonna be like, I don't care. But instead of waiting till 2020 from 2026 to 3,000 or let's say 2040, and then that number goes from 70 to 30.
Yeah.
Instead of waiting, then you could simulate that and be like, you know, this is the problem, and which issues. It could also be a way to kind of categorize which issues should be tackled.
Yeah.
You know, first, second, third, or whatever, right? You know, like, okay, well, if we keep on with this plastics stuff, this is going to cut our biodiversity down to 50 in 20 years. You know, because of this simulation, we could run it. Yeah, that whole idea. I could keep going on and on, but like, yeah, that's how I think it could be very
I think in a
applicable.
way, we're kind of doing that already, right?
Yeah.
You know, climate change.
Mhm.
They're saying, oh, by 2100, the world will be so many degrees hotter.
Mhm.
And, you know, sea level rise is going to go up this amount.
Mhm.
But still, you don't see a lot of news nowadays about how this is like such a pressing issue, even though every model is saying the same thing.
Yeah.
That this is a critical disaster that we have to address,
Mhm.
but it's not being addressed. So, I guess, what are your thoughts on how we fix that disparity between?
Me personally, I think it's just because it's hard to tell a human or hard to tell a person. Let's just say humans. Humans only care, and I find this to be a reality even within ourselves. You care about what you care about. You care about
Yeah.
what's useful to you. You care about what affects you immediately. And I feel like that's an organismal, if that's even a word.
I think so.
An organ, like it's an organism wide. Like if you're an organism, you care. Like for instance,